In this video, we're going to be doing some simple calculations related to field size scaling. So in radiation therapy, we often have to scale field sizes from one place to another so that we know how big the field is at different locations in the treatment room. And for field size scaling, remember that the field size, my pen's not working, field size is defined at isocenter. And for most of our radiation therapy machines, isocenter is a 100 SSD. So if ISO is here, this distance is 100 centimeters. And then this width here would be the field size. But the field continues through the patient. We may want to know what the field size is here, below the isocenter, or up here above the isocenter. And field size scaling works by using similar triangles. So if you remember similar triangles, we have maybe this triangle right here, this length right here, and we know that if we're looking at this length and that height, that can be related to this length and this height by a simple ratio. Height divided by length is equal to the other height divided by the longer length. So the length here and the height here ratioed is the same as the smaller one. So for this example, let's say we have we're treating total body irradiation, TBI, which is treated at a field size of 30 centimeters by 40 centimeters. And the patient is set up at 6 meters away. So the midplane depth, the patient is at 6 meters. So what's the field size at 6 meters? If this field size 30 by 40 is at ISO, how big is it at 6 meters? Well, we can figure this out. The field size scaling works whether it's symmetric or asymmetric jaws. So in this one, let's say like this is 6. We'll say this is 6 meters away. This is the field size that we want to know is equal to what? And here we'll say this is the 40 centimeters field size at 100. So using similar triangles, 100 centimeters. I'm just quickly going to convert this. 100 centimeters is equal to 1 meter. This is 6 meters. So I get a field size of 40 centimeters at 1 meter is equal to whatever this field size is at 6 meters divided by this length here, 6 meters. And in this equation, all I have to do is solve for the field size. So to do that, I'm going to multiply both sides by 6 meters. So I'm going to get 6 meters times, put it across there, 40 centimeters divided by 1 meter is equal to the field size. And you can see the units don't actually match up, right? I have meters here and centimeters there, but these meters are going to cross each other out. So I really just get 6 times 40. 6 times 40 is equal to 240. We keep the units of the field size. Centimeters is equal to the field size at 6 meters away. So that's one field size. The other one, 30 centimeters. We do the exact same calculation. We can do 6 meters times 30 centimeters divided by 1 meter is equal to the other field size, which is equal to 180 centimeters. 180 centimeters at distance. So by the time this 30 by 40 field gets out to the patient, it's 40 centimeters across, 30 centimeters high, and we have the patient laying horizontal in the field. So it fits pretty good. Another example that we can do, let's say like we have a field size of 5.5 centimeters by 6 centimeters. And we want to know what that is at an SSD of 90.5 centimeters. So we have to take the field size at 100 centimeters and scale it to 90.5. So it's going to look like this. 5.5 is one triangle at 100 centimeters. And we want to know what it is at 90.5. So this length here is going to be 90.5 cm. And we want to know what this field size is right there. So we got field size that we don't know divided by 90.5 cm is equal to 5.5 centimeters divided by 100 centimeters. We just have to multiply both sides by 90.5 centimeters. Field size is equal to 5.5 centimeters times 90.5 centimeters, all divided by 100 centimeters. If I get my calculator out, 5.5 times 90.5 equals, divided by 100 equals 4.975, 4.9, we'll call it 9.8, we'll round centimeters. I could also round this to, if I wanted to do the number of significant, there's 3 here, so we'd use 3. So that's one of the field sizes. The other one I want to scale is the 6 centimeters. So I could just substitute it in here. Field size is equal to 6 centimeters times 90.5 centimeters, all divided by 100 centimeters is equal to, just run through it again, 6 times 90.5 divided by 100 equals 5.43 centimeters. So a field size of 5.5 centimeters by 6 centimeters at 100 scales to 4.98 by 5.43 centimeters at 90.5 centimeters. That'd be useful if you had like the SSD of 90.5, you wanted to verify field size at skin surface, you could scale it back, take your ruler out, measure exactly what the field size is, and then you'd be done.